Okay, see, we are discussing about some tests through which we should be able to determine settlement and other things, and those are basically in situ tests. And related to in situ test, we had done brief discussion in the previous class, and we have finished our discussion at standard penetration test. I think we are somewhere here, right? Height of the fall, and then how to decide what should be the correction of standard penetration test and other things we have discussed. Okay, so after this let us move to another one test, which is termed as what is called plate load test. Okay, so we'll discuss today about plate load test. Okay, so plate load test, if you see IS 8009, then for calculation of settlement in sandy soil, or in some cases of clay soil also, you can directly use plate load test for finding out the settlement directly at the site. Okay, so you need not to use any formula, you need not to calculate any modulus of elasticity or anything. What you have to do, you can directly just carry out the plate load test, and using plate load test you should be able to find out uh, what is called the settlement amount. Okay, so let's see what is plate load test. So if you see plate load test, so plate load test, you can refer Indian Standard Code 1818 1982. Okay, so in the Indian Standard Code, the description of plate load test and other things are given. Okay, so where you need to use this test? So you can use this test for finding out the bearing capacity. So the load is applied such that rate of penetration remains constant. So in case of plate load test, what you'll have to do, you'll have to keep your rate of penetration constant, and you'll have to produce a load settlement curve. If you remember our bearing capacity initial discussion, where we have discussed about different types of failure in soil, basically the shear failure in soil, that is general shear failure, local shear failure, punching shear failure. If you remember those curves, from where we have decided on general shear, local shear or punching shear, those curves are basically the load settlement curve. That means in one axis, along the x axis you plot the load, and along the y axis you plot the settlement. So from the load settlement curve, you can develop some equation to obtain the undrained shear strength from ultimate bearing capacity. Okay, so from the ultimate bearing capacity, you should be able to find out the shear strength of soil, or vice versa. If you can find out the shear strength of soil, you should be able to find out the ultimate bearing capacity. And the second part is very important, that is to find out the immediate settlement of soil. See, you require actually elastic modulus E, right? So if you remember the formula, mu into B 1 minus mu square, P into B 1 minus mu square by E into I. So the immediate settlement calculation formula, there you see the E is basically the elastic modulus. So you can find out the elastic modulus of soil using this plate load test also, because once you have this load settlement curve, it is just like the stress versus strain curve you plot for your what is called the steel test, or in the UTM machine, universal testing machine. When you do the stress strain curve, you have learned it in your strength of material course. Just like that, if you carry out in case of soil the plate load test, you should be able to produce the load versus settlement curve, and from the load versus settlement curve you should be able to find out the elastic modulus of soil. Okay, so let us now try to understand what is the setup, and what is the apparatus arrangement for this plate load test. Okay, so for the plate load test, you first require a loading platform. Okay, so I'll just go back and come back here also. let's see the next slide. So you see, you require a loading platform. First let me explain the diagram, then I will go to the writing part of the thing. Okay, so you see, this is actually the setup, typical setup of kind of a plate load test. See, there are two types of general plate load test being carried out on the in the field. Okay, one, in one setup you observe it is given as gravity loading platform. Gravity loading platform, that means only using gravity load you will be just pushing the plate inside your soil mass. And the other one is the reaction loading platform. So in the reaction loading platform, actually you will be using some kind of jack. So jacking arrangement will be used in case of reaction loading platform. This is the only difference between your what is called your two types of setup. One is gravity loading and one is reaction loading. Okay, and if you see the setup, you see the 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 point where you want to find out the settlement, or you want to find out bearing capacity, or you want to find out the modulus of elasticity of soil, you cut the soil up to that desired depth. So as required, if you see, you go up to that depth. So you excavate the soil just like the foundation excavation, just like the foundation excavation, you just excavate the soil. And what will be the size of this excavation, we will come to that later. Okay, exact size of the excavation and other thing. And then what you do, you put a small plate. So there will be a test plate, and what will be the size of the test plate, I will come to that later. Okay, so this test plate you put at the position where you want to test for the soil settlement or bearing capacity or modulus of elasticity. So you put a test plate over here. Here you see the thin test plate you put over here. Okay, and on top of that test plate you arrange for one loading platform. You see, this is a loading platform. And what is this? Basically this is a kind of a arrangement through which the load will be transferred to this plate. Okay, and you see, on top of this arrangement, you see, so basically loading is being transferred, you see, through a 15 centimeter diameter loading column. Okay, so this is basically a circular loading column through which the load will be transferred to this plate. And from where you will be getting the load? You see, there is a mild steel plate placed over here, and there is a loading platform on top of that. Basically this is a wooden plank, and on this top of the wooden plank you can just keep on adding on the sandbags. Okay, so bags full of sand. Okay, so you just put the sandbags on that platform. So as and when you put the sandbags, before that you take a weight of that. So gradually if you go on adding the sandbags on top of that platform, what will happen? That will create some incremental loading which will be transferred through this loading column to the plate at the bottom. And where is the plate? The plate is just sitting on top of the soil. Okay, so at the foundation depth the plate is basically sitting. So once you put the load on that, what will happen? The plate will be getting penetrated inside the soil mass, because as you go on increasing the load on the soil mass, obviously there will be some settlement inside the soil. Okay, so how do you measure it? You can measure this using some arrangement of dial gauge. You see, here is a one dial gauge and there is another one dial gauge over here. Okay, so you put some dial gauge over here, and using those dial gauge you can measure how much penetration is happening. So you can easily understand what you have to do. You are basically, I'll show through this figure. You see, along the x-axis you plot just the load, and along the y-axis you plot the settlement. So you see what you will have to do. Here you are putting sandbags, so sandbags are creating some load. So what you will do, let's say 10 kg load you put over here, so you plot this 10 kg load over here, and what you are doing here over here, you will just change that load to stress, that is kg per meter square. So how do you do it? The load will be actually getting transferred to this plate. So divide the area of the divide the load by this area of the plate. So you will be getting basically the stress created on the soil, and corresponding to that, through this dial gauge you should be able to measure, because of that load, what is the settlement inside the soil. So basically what you will have to do, as you are going on increasing the load here, so at this point when the load is over here, you find out what is the settlement. When you are here, you find out the settlement. When you are here, you find out the settlement. So you put the points inside the graph and join it with a smooth line. Okay, join it with a smooth line, and that is going to give you actually the load settlement curve of the soil. So this is what is actually the gravity loading platform in case of plate load test. See, there is another one arrangement IS standard code also says, that is 1888 code. If you see 1888 code, where the plate load test is explained in detail, there you will see another one arrangement is given, that is actually called reaction loading platform. Okay, so typical setup for the reaction loading platform. So in the reaction loading platform, if you observe, you see almost the arrangements are same like the gravity loading platform, only there is a difference. Only there is a difference at this point. You see, at this point you see you have put a mild steel plate, and on top of that there is a wooden joist is being placed on top of this column. Okay, instead of that, you see in case of reaction loading platform, you will be putting a jack over here. Okay, a jack will be placed over here. Okay, so once you place the jack over here, there is another one difference if you observe. See, in case of gravity loading platform, if you observe, the dial gauges are put on top of the hole. That means this is your excavation hole. The dial gauges are top at the ground, put at the ground level basically. Okay. On the other hand, if you observe, in case of reaction loading platform, you see the dial gauges are placed at this point. That means dial gauges are now attached directly to these plates, directly to the plate. Okay. On the other hand, in case of gravity loading platform, you see dial gauges are not directly attached to the platform. Instead, using this clamp arrangement, there will be a platform attached to this column. On top of that, there will be dial gauge attached, and as and when the plate will be getting settled over here, this clamped arrangement will also go down, and you should be able to find out the settlement from this level of the platform. These are the only two difference between gravity loading platform and reaction loading platform. You should understand it clearly, because in many cases in competitive exams, to confuse you about the problem, these terms are used, that gravity loading platform is used, and in that the dial gauge is placed at the top of this ground. So in the dial gauge this reading has come, but you see thing is exactly same for a gravity loading platform and reaction loading platform. So you should not get confused. Only difference is reaction loading platform uses a jack, gravity loading platform does not use a jack. It transfers the load directly using the gravity mechanism, and the jack and the dial gauges are being placed at the top of the ground. Dial gauges are not being placed at the level of the plate. On the other hand, in case of reaction loading platform, dial gauges are placed at the level of the plates. Okay. So understanding this mechanism of plate load test setup, let us go back to the theoretical part. So what is the apparatus we are talking about? So we are talking about loading platform. You have seen. So loading platform, truss of sufficient size and properly designed member so as to estimate load reaction. Then hydraulic jack you should use in case of reaction loading platform with required capacity. Then bearing plate, this is very important. So you must be using the bearing plate of proper size. So bearing plate, which is the bearing plate? Bearing plate is nothing but this one, test plate. So this one is your test plate just at the bottom of the ground, bottom level, whatever that plate you are placing, that is actually your bearing plate. So the bearing plate, either it may be circular or it may be square, okay, of mild steel. It should be prepared of mild steel, and the thickness of the bearing plate, you must remember, it should not be less than 25 millimeter, okay, and the size of the bearing plate may vary from 300 to 750 millimeter. That means either it may be 300 millimeter diameter to 750 millimeter diameter, or it may be 300 by 300 square or 750 by 750 square, okay. So depending on the size of the excavation pit, you can use, depending on the size of the excavation pit, you should be able to use the bearing plate. But you should remember the size of the bearing plate. So either it may be 300 or it may be 450 or it may be 750, something like that, okay. So 300 millimeter by 300 millimeter square, or 750 millimeter by 750 millimeter square, or 450 millimeter by 450 millimeter square, such kind of bearing plates you can use. The bearing plate should be prepared of mild steel, and the size of the bearing plate should not be less than 300 millimeter. So you cannot have a bearing plate for doing plate load testing which will be, let's say, 100 millimeter by 100 millimeter or 150 millimeter by 150 millimeter, okay. Now next point is the settlement recording device. So you should be using a settlement recording device that is dial gauge with 25 millimeter travel. So you should use a dial gauge with 25 millimeter travel capable of measuring settlement to an accuracy of 0.01 millimeter. So the dial gauge should be such that it should be able to measure the maximum settlement up to 25 millimeter, okay. It should not be less than that, and the settlement should be measured to an accuracy level of 0.01 millimeter. That means the least count of the dial gauge should be 0.01 millimeter, okay. And the last one is your datum beam or rod. So datum beam or rod, sufficient strength capable of maintaining straightness when fitted on two independent supports fitted with arms or magnetic bases for holding dial gauges. That means in case of gravity loading platform this is true. In case of gravity loading platform, this is actually your datum rod. So it should be such that it should be having sufficient strength that it should not bend, right. So if it bends, then your dial gauge reading will not be proper, okay. Sorry. Now coming to the this is the theoretical part of it, and now let's see from this how do you get the data for calculation of settlement. That means how do you use plate load test for calculation of settlement, okay. So you see in the procedure section, if you go to 1888 code, you should be able to see the test procedure, and it is being said that the test shall be conducted at an elevation of proposed foundation level. So it should be conducted at the foundation level. So where you want to construct the depth of the foundation, up to the depth of the foundation, you should cut the pit, and then at that level you should test it, okay. Next is for clayey and silty soil and for loose to medium dense sandy soil with N less than 15. So in this section you see which size of plate you should use, that is being defined. So you first understand that how SPT is important. So if you want to do plate load test, ideally before choosing the size of the plate, what you should do, you should carry out the SPT at that location. That means standard penetration test should be done surrounding that location. And if your SPT value is less than 15 for clayey or silty soil, then you should use a 450 millimeter square plate. Okay. In case of dense or gravelly soil, sandy soil, dense, sandy or gravelly soil, where you can expect that the standard penetration value between 15 to 30. Okay. So in such case, you can use the plate size of 300 to 750 millimeter, depending on the practical consideration of reaction loading and maximum grain size. That means you can use 300 millimeter by 300 millimeter, you can use 450 millimeter by 450 millimeter, or you can use 750 millimeter by 750 millimeter. Okay. So depending on the size of the grains, you should be able to use it. Okay. So the more the coarser the soil, you can use the lesser size of the plate. Okay. Now the third one, you see, the side of the plate shall be at least 4 times the maximum size of the soil particles present at the test location. So this is very important. The side of the plate, that means if you see the particle size is, let's say, one maximum particle size, let's say 20 millimeter, then your size of the plate shall be at least 80 millimeter. It cannot be less than that. At least 4 times the maximum size of the particle present in that location. So that is very important. Okay. So I think just few minutes back I told something which is not correct. I think by mistake I told it, that with the increase in the particle size, your size of the plate should increase. Actually, it should not decrease, it should increase. Okay. So with the increase of the particle size, so if you are testing a very gravelly type of soil, highly gravelly soil, then you should be doing it with larger size of the plate. Okay. Now next part is the rate of loading. That is very important. So you should use the load increment for 1 kg per centimeter square. This is very important. 1 kg per centimeter square, you should convert it to Newton per millimeter square or megapascal if you want to convert it into SI unit. Okay. And then the next part is very, very important, that when you should observe the settlement. So the settlement should be observed for each increment of load after an interval of, that means every 1 minute, 2.25 minute, 4 minutes, 6.25 minute, 9 minutes, 16 minute, 25 minute, and thereafter an hourly interval to the nearest 0.02 millimeter. What does it mean? It is just like your consolidation settlement. If you remember the consolidation settlement test, in that oedometer test, if you remember, the readings were taken after some minutes, 1 minute, then 2 minutes, then 4 minutes, then 6 minutes, 8 minutes, something like that. Exactly the same way in case of plate load test also, you should be taking the reading at an interval of time, and then you should plot the reading. Okay, that is very important. So the reading interval is being defined through the Indian Standard Code. So you need not to remember exactly the reading values, but you should have some idea. Okay. So you need to see this plate load test that way is a very time consuming test. So in the site or at the site, you may have to wait for 3 days, 4 days, 5 days to get the proper reading from the plate load test. Okay, because after you put the load, you will have to wait and see up to 25 minutes, 1 minute, 2.25, 4, 6.25, 9, 16, 25, and after that hourly interval also you should see, and you should observe that whether at the particular load the soil is getting settled nearest to 0.02 millimeter. That means you should be waiting for hours together to check whether the soil is getting settled because of the load you have put on the loading frame, then only you should be able to then only you should be you should increase the loading on the loading frame. Okay. So until and unless the settlement is getting subsidized, until then you will have to wait and see, and then only you should be able to you should be increasing the load. Okay. So that is that okay. So after this, you see, if you see the load settlement curve, so in the load settlement curve, if you observe, I have told you earlier also that along the x axis you plot the loading and along the y axis you plot settlement. So depending on the type of the soil, depending on the test process at the site, you should be able to find out the load versus settlement curve. And these curves are just indicative curve. You don't think these are the curves you are going to get at the site. So these are the indicative curves as given in Indian Standard Code, just to give you some idea about how you will be getting the curves for different types of soil. So you see, in case of dense soil, in case of dense cohesionless soil, you should be getting a curve something like this. And you see, this is the behavior of general shear failure. Okay. In case of loose to medium cohesionless sand, cohesionless soil, your curve may be something like this. And in case of cohesive soil, your curve nature may be something like this. But don't think that you are going to get the curves exactly something like this. Your curve, your nature of the curve will totally depend on your testing process. Okay. And the reading, whatever you will be getting in the field, you just plot the loads along it, or you can say not the load, you can say the stress at the soil along the x axis and the settlement of the plate along the y axis, and thus you should be able to get it the load settlement curve. And from the load settlement curve, see, you should be able to find out the value of your modulus of elasticity also, because you see, modulus of elasticity is what? Stress divided by strain, right? So stress divided by strain. So in such kind of curve, at particular point where the failure is happening, so in such kind of curve where the straight line is coming, so you see what is the stress, and from this you should be able to find out, from the settlement you should be able to find out how much is the settlement, how much is the strain in the soil, and from the strain and stress you should be able to find out the modulus of elasticity of the soil. Okay. Now coming to the last part of this discussion of plate load test, you see, the beauty of the plate load test is, from different studies by different scientists and soil mechanists, people have come up with a formula to find out the settlement of the footing from the settlement of the plate. That means a relationship can be established between the settlement of the footing and the settlement of the plate. And in that relationship, you will have to use the width of the footing and width of the plate, or breadth of the plate. Okay. So you see, you are testing the plate load test, let's say, with a 300 millimeter by 300 millimeter 300 millimeter by 300 millimeter what is called plate size. Okay. So if you are testing it with a 300 millimeter by 300 millimeter plate size, you please observe over here in this formula, it may confuse you. In some books or some cases sorry, this 0.3 is written as 30. In some, sorry, what happened? See, in some books you will observe this 0.3 is written as 30, here also 30. in some books you will see this is written as 300, this is also written as 300. Don't worry about that. Okay, what does it mean? If you are using this BP and B value in meter, then it will be 0.3. If you are using this BP and B value in centimeter, then it will be 30. Then it will be 30. Okay, so is it clear? So that way you should, because you see this is this figure, this total thing is basically dimensionless. You will have to produce a dimensionless quantity, because you see B by BP, whether you use it meter, centimeter, millimeter, doesn't matter, but the unit of B and unit of BP should be same. If you are using meter, it should be also meter. But if you are using in this formula 0.3, this is a constant value in this formula. So 0.3 if you are using, then you must remember your BP and B should be in meter only. If you use this 0.3, if in many books you will observe this formula is given as BP plus 30, then B plus 30. If you use the value in the formula, if you use BP plus 30 and B plus 30, in that case your BP and B value should be in centimeter. Okay, so you need not to get confused. You can remember this Indian Standard Code value. This will help you to get the every answer correct. You need not to worry about it, whether it will be 30, whether it will be 300, whether it will be something else. No, it will be, you remember 0.3, and if you use 0.3 in the formula, then this is where the confusion comes. That's why I am repeating it again and again. Okay, so if you are using 0.3 this value in the formula, then you take the width of the plate in meter, you take the width of the foundation in meter. So let's say you are using a 300 by 300 plate. So how much meter it will be? 0.3 meter. If you are using 450 by 450 plate, then how much will be the value of BP? BP means breadth of the plate. It will be 0.45 meter. Now you are testing for the testing with a 0.45 meter plate, and at that position where you are testing, there you want to set up a foundation of, let's say, 2 meter by 2 meter or 2 meter by 3 meter. So if you want to set up a rectangular foundation, let's say of 2 meter by 3 meter, then what is the width of the foundation? Sorry, the width of the foundation is 2 meter, right? So once the width of the foundation is 2 meter, that means your B value will be 2 meter, your BP value will be 0.45, here it will be 0.45, here it will be 2, and then you calculate, see there is a squared term over here, and then you multiply it with the settlement of the plate. Okay, so you find out what is the maximum settlement of the plate. So from the settlement of with the settlement of the plate, you multiply this term and you are going to get the settlement of the footing. So what you are actually doing, you are testing with a 450 plate to predict the settlement of a footing of original site. So this is the beauty of the plate load test. So I think you should now be clear about this plate load test and standard penetration test, right? So you see the standard penetration test is also required for your plate load test. Why? Because the dimension of the plate to be chosen will be driven by the result as you get from the standard penetration test. So in many competitive examinations, in GATE examinations or engineering examinations, you will see the questions. I will discuss those problems, I will discuss those things in the class also. Some problems I will take from standard penetration test, then settlement calculation. After this discussion, in the next class we will be doing it. Today I think in the next class there is exam, so in the next week only we will be taking it up. So in that you will observe that standard penetration test and plate load test are very two important tests to understand, because these are the two tests which can be carried out directly at the field to explore the characteristics of the soil. So, see the major characteristics of the soil, that is the sorry, that is the shear strength of the soil, the bearing capacity of the soil, the settlement of the soil, all these things can be found out using these two tests. So, if you can understand these two tests and if you can understand the setup of these two tests, you should be able to very easily find out the what is called the bearing capacity and settlement of the footing. Okay. So, is there any doubt up to this discussion? Any question?
No, sir.
No. Everything you understood, Utkarsh?
Yes, sir.
Okay, so books, you are some Utkarsh, I think you are asking about books, right? So you can buy any book. I think the book by S.K. Garg is good, because that covers everything about your soil mechanics 1, soil mechanics 2, means it's a good book for preparation of competitive examinations also. Lot of problems are worked out in there. Okay, previous year engineering service questions as well as some gate questions and other competitive exam questions are also given in S.K. Garg's book. So I think you can take S.K. Garg's book, or you can use B.C. Punmia's book. You can use V.N.
Sir, what about Dr.
हाँ सौरभ बोलो. What about?
सर बोल रहे थे डॉक्टर बीसी पूर्णिया का बुक.
हाँ, B.C. Punmia is good one.
Satyana.
Good one. You take it. No problem. If you have bought it, you can use that also. Okay. Why I am see in the Garg's book na, in the Garg's book many problems
Yes,
from
sir.
engineering service and others also solved. Okay, so that will give you some feel as well as confidence that you are able to solve the things. Okay, so that is what I am saying. Okay, and second thing is now the books are being issued in the college. Okay, so if you want to pick up, you can come down and one day and you can pick up the books from the college. We are hoping that in the month of January or January the college should open, but God knows when it will open. Okay, so let's see how it happens. Okay, but if you want to really pick the books, all the books are now being issued from book banks and other places. So you can come down, you can submit your old books and you can issue the books, because this is a very important semester you are studying. Basically all the important subjects are there, so you can pick up the books from library. Okay, so book bank books as well as library books you can pick up. You can come one day and you can pick it up. Okay, so about class test, you have any doubt? If you have any doubt, class test. So around 145 na class test is at 145, right?
Yes, sir.
So at
Yes, sir.
145, around 145 you will be getting the link of the class test. Okay, so what we have done in the soil mechanics, Shobhan sir will send, Shobhan sir will send for both the section. Okay, and there will be 5 objective questions and then and 4 subjective questions. So you will have to work out and then you will have to answer it. Okay, very simple problems are given. Just use your thinking process. You see to it the codes also. If you cannot remember the code values, so Indian Standard Code 6403 values, right, for finding out values for rectangular footing, what is the shape factor, what is the depth factor, you may have to use some such kind of things. Okay, so you can check those and you can put the correct values. You work out the problems on your paper and then keep those papers, so we can ask you for verification. Okay, that you send the paper where you have worked out the problem, and then only we will be giving you marks. Okay, so not to everybody, randomly we can ask you. Okay, or we may not ask at all. So it's all up to your honesty. So I am believing on you will be doing it honestly, right? So please do it. Very simple
Yes,
things
sir.
are given. Okay. So you
Yes, sir.
just try it your own. Okay. It's not to means copy from here and there. You just try your own. Try to learn and work out the problems. You use your codes. I have shared everything from bearing capacity. Okay. So if you cannot remember the values, you use standard code, but you will have to remember those values. Okay. One or two problems I have given from previous year, very old previous year GATE questions also. Okay, very simple problems I have given. Okay, so you just try them. Okay, it's not very difficult. You can just use the simple formula and you can solve the problems. Okay. One or two things you should remember, that where you have to use depth factor, where you have to use shape factor properly. Terzaghi's factor and Indian Standard Code factors may be different. You should remember that. Okay. Then you should remember cohesionless and cohesive soil. Okay. So in case of a cohesionless soil, if you use a purely purely cohesive soil. So purely cohesive soil means what? Phi is equal to 0, right? So in case of phi is equal to 0, what will happen?
Clay, sir.
Clay, but what will be the bearing capacity factor values? You should remember that. Okay, for phi is equal to 0, NC, NQ, N gamma value from Indian Standard Code as well as Terzaghi's value you should remember. Okay. Second thing is, you should very carefully read the problem and see the position of the footing. Okay, whereas the footing is on the ground, or footing is at some depth, or footing is under the water table, those things you should observe. Okay. So there may be problems where the footing, just to check your understanding, footing may be placed on the ground also. Okay. So just on the surface level footing is placed. Okay. So in that case what will happen? On the surface level, if the footing is placed, then your depth will be equal to 0, right? Depth of the footing will be equal to 0. So D will be equal to 0. So you should use your mind and you should use your thinking process to just answer the questions. Okay. So I think you have prepared well. So hope you do well in the CA1. So thank you. I'll just take the attendance and
Sir,
stop it. What happened?
excuse me sir.
Excused. बोलो.
सर बोल रहे थे कि वर्कआउट प्रॉब्लम्स के लिए उसको पीडीएफ बना करके भी इसको मतलब
हाँ, पीडीएफ बना के साथ में रखना है. ठीक है, कहीं पे डालना नहीं है, सिर्फ खुद के पास में रखना है. अगर मन किया तो स्वाति कुमारी से पूछेंगे. ठीक है, कि स्वाति कुमारी ने खुद ने वर्कआउट किया कि उधर से ले लिया, उत्कर्ष से ले देख के कर दिया. ठीक है, because all the problems are given with options. Okay,
नहीं सर पूछ
so please try your own. Okay.
ओके सर.
Okay, thank you, best of luck for your CA1, all the exams. Okay, so see you later. Okay, thank you. You can leave the meeting.
थैंक यू सो मच सर.
Thank you.